Okay, so here we have another problem in the impulse momentum unit. A tennis player receives a shot with the ball, there's our mass of the ball, traveling horizontally at 50 meters per second, and returns the shot horizontally in the opposite direction at 40 meters per second. Question A, what is the impulse delivered to the ball by the racket? Okay, so here's the key word in this problem, impulse. Since I know there's an impulse, then I know that I'm not going to be using my law of conservation of momentum, and I'm going to be looking at external forces acting in some way. So here's my initial picture of what's happening. I have a tennis ball coming in, and then at the end, I have a tennis ball going out in the opposite direction. And I can actually say that this is 40 meters per second in the opposite direction, and this is 50 meters per second. Now, here's one of the keys to this problem. It's important to note that these velocities are in opposite directions. So one of them has to be the negative direction, and one of them has to be the positive direction. In this case, just based how I drew it, I'm going to say that my initial velocity of 50 is in the negative direction. Okay. Now, in order to calculate the impulse delivered by the racket, remember that impulse is equal to the change in momentum of my object. So my impulse is equal to my mass times my change in velocity of the object I'm talking about and the object that the force is exerted on. In this case, that is the tennis ball. So impulse equals the mass of the tennis ball, it tells me, 0.060 kilograms. In order to find a change in velocity, remember, it's final velocity minus initial velocity. So my final velocity here is 40 meters per second minus my initial velocity, which is negative 50 meters per second. Then I plug this into my calculator and get a value, which in this case is 5.4 Newton seconds, or another acceptable answer is 5.4 kilogram meters per second. Remember, those are the same thing. Okay, so there's the answer to question A. I can even write that up here. 5.4 Newton seconds. Question B. If the ball was in contact with the racket for 0.035 seconds, what is the average force exerted on the ball? Okay. I also know that my impulse is the force applied to my object times the amount of time it is applied. And that's based on the impulse momentum theorem. So I already figured out the right side of this over here. So I know that 5.4 kilogram meters per second is on this side. I know force is what I'm looking for, and 0.035 seconds is my time. So in order to solve for this, divide both sides by 0.035 seconds. Cancels out, divided by 0.035 seconds. Okay. And I end up getting a force, which is 154.3 newtons. Now, the key to this problem is knowing how to read it. After you know what the problem is asking you to do, it's relatively easy to pick out the correct equation. So, an impulse was applied. An average force is being looked for. A time is given. I'm looking at an external force acting on my object, which is the tennis ball.